Our Electron rocket stands tall on Pad A at Launch Complex 1 in Mahia, New Zealand. We are preparing for liftoff at 9:43 a.m. local time or 20:43 UTC. Welcome to launch day for our next Kinéis mission, IoT for you and me. My name is Sam Peters.
And I'm Matt Tier, and we'll be sharing live updates with you as we go to space once again in just over 18 minutes from now. After a record-breaking year in 2024, we launched a total of 16 Electron and HASTE missions. Today's launch is the first of 2025, and it kicks off our busiest launch manifest yet.
Today's mission is our 59th launch overall and our 4th for the team at Kinéis, an Internet of Things constellation operator based in France. We have been Kinéis' exclusive launch provider to date and have completed 3 successful missions for them last year, deploying 5 satellites per Electron launch. Today, another 5 satellites will join those already in orbit. Now, today's launch is the 4th of 5 we have booked for Kinéis to deploy their entire constellation. The first 3 missions were launched in June, September, and November 2024. Each of these missions lifted off from LC-1 in Mahia on board an Electron launch vehicle. Across the 3 missions to date, we've deployed 15 Kinéis satellites to orbit, and like all Electron missions, each launch received a unique name. The team at Kinéis have had a lot of fun with their mission names so far, drawing inspiration from the objective of their constellation, which enables both IoT and AIS, or Automatic Identification System. They've aptly named their missions to date No Time to Lose, in a nod to the company's location in France, Kinéis Killed the Raid IoT Star, and ICE AIS Baby. Today's mission has been dubbed IoT for you and me, and that leaves just one more upcoming mission to be named. But you'll have to wait and see what the Kinéis team have dreamed up for the 5th and final launch. They have booked this as part of a bulk buy deal on Electron.
No matter what the mission name, each liftoff is spectacular, and that sight of Electron pierced in the sky never gets old. For today's mission, there are once again 5 satellites inside Electron's fairing. They're headed to a 647-kilometer orbit at an inclination of 97 degrees. Each of the 5 satellites will deploy from the payload plate on Electron's kick stage at staggered intervals. This is to ensure they settle into their own distinct orbits. That moment of deployment will occur around an hour and 6 minutes after liftoff. So, while we wait for the countdown, let's take a closer look at what Kinéis' constellation enables.
Kinéis is a French company based in Toulouse. They are satellite operators and global connectivity providers dedicated to the Internet of Things. Mountains, oceans, deserts, 85% of the planet has no network coverage. In 2020, Kinéis raised a large amount of 100 million euros to address this global issue. Today, the company is following through and will deploy a constellation of 25 nanosatellites that will enable it to connect to a multitude of objects anywhere on the planet in near real time. Kinéis is convinced that this transmission of information, made possible by satellite connectivity, will enable it to respond to crucial challenges for mankind, its activities, and its environment. On the environmental front, for example, Kinéis' connectivity can detect a fire outbreak in less than 15 minutes, thus considerably reducing the extent of the outbreak and reducing the loss of property and human life. The same goes for monitoring water levels to prevent flooding and use this dwindling resource. The applications are endless, whether for locating, monitoring, or alerting. Since its creation in 2018, Kinéis and its teams have been working with this objective in mind. Their 25 nanosatellites that weigh only 28 kilograms are real technological gems. The retractable UHF antenna that, for example, can hear a bird sing within a rock concert 650 kilometers from Earth. They have been fitted with thrusters to ensure they stay on track for their mission. Some even carry children's drawings. At the same time, Kinéis has deployed many ground stations worldwide and have a sovereign infrastructure to guarantee data transmission to its clients. Today is a decisive day. Rocketlab will launch the 4th rocket. 5 additional Kinéis satellites will orbit in space, bringing the constellation to 20 satellites out of 25. This new launch will considerably strengthen the service's performance. There is only one more launch before the final deployment of the constellation. Kinéis' team can't wait.
Not long to go now until the next 5 Kinéis satellites are headed to orbit in just 13 minutes remaining in the countdown until today's instantaneous liftoff opportunity.
All right, at T minus 13 minutes to liftoff, let's check in with the launch operators in mission control to hear that go, no-go poll for today's launch. Operators based in 2 locations will indicate their readiness to the launch director, and as always, what we are looking for is greens across the board. Operators based in range control, which you can see on the right side of your screen there, are located in Mahia, just a few kilometers back from the launch pad itself. This team is typically monitoring ground systems and the range exclusion zone. Our other team of operators, which you can see on the left side of your screen, are based right here in mission control, which is one of several that we operate. They are typically monitoring vehicle systems, payload health, and other factors like weather. Let's listen in for their calls as they work towards the poll, led by Launch Director Paula Tares Serralonga.
Tour stations LD in Mission Core proceeding with a go-no-go sequence stage.
Stages go.
Avionics,
Avionics is go.
GNC,
GNC's go.
Vicon,
Beacon is go.
T1,
T1 is go.
GC,
GC's go.
PLS,
PLS is go.
RSO,
RSO is go.
MET,
MET is go.
MM,
MM's go.
LD sub.
LD SEP is go.
Go-no-go sequence complete. We are T minus 11 minutes 21 seconds and counting. We are go for terminal count auto sequence starting at T minus 10 minutes. From this time, the 3-word hold procedure is in effect.
You heard it, folks. We are go for launch, and the count is proceeding. We're at T minus 10 minutes until liftoff. Now, if you've been watching Electron launches for a while, you know that we often have an availability window in which to lift off the pad on launch day. Typically, this is 2 to 4 hours long, and it gives us the flexibility to select the perfect liftoff time on the day based on optimal weather conditions. Today's mission, like all the Kinéis launches before it, is a little different because it requires an instantaneous liftoff. That time is dictated by customer requirements, which is a benefit of flying dedicated on Electron. By having complete control over the launch time, our customers can ensure their spacecraft get deployed at exactly the right time and to exactly the right location. So for today's launch, that means it lifts off at precisely 9:43 a.m. local time, or it doesn't go. If we did need to stand down for any reason, we'd come back another day to hit that liftoff time.
Today is all about launch, but as we like to say around here, there are more than just rockets in this lab. As Electron progresses through the count, let's take a look at some of the other exciting missions our team have been enabling. Right now, a Rocketlab designed and built spacecraft is orbiting Earth. It is supporting a capsule for Varda Space Industries, which is a microgravity-enabled life sciences company. They process materials in orbit and return them to Earth.
Varda's W2 mission is supported by Rocketlab Pioneer spacecraft that provides power, communications, propulsion, and attitude control to Varda's 120-kilogram capsule. Inside that capsule are some innovative payloads, including a spectrometer from the Air Force Research Laboratory. The capsule also employs a heat shield with a thermal protection system developed in collaboration with NASA's Ames Research Center. These payloads are in addition to Varda's expanded pharmaceutical reactor, which will increase the capability and capacity for pharmaceutical processing on orbit.
Following the payload processing phase in orbit, Rocketlab spacecraft will guide and position Varda's capsule for deorbit. This will enable a hypersonic re-entry and recovery at the Coonabar Test Range in South Australia. Let's take a look back at where our journey with Varda started.
This is a totally groundbreaking platform. The ability to use a propulsion system on a re-entry probe back to Earth is pretty sweet.
We built the solar panels, we built the structure, we built the propulsion system, we have all the software that we built, the reaction wheels with star trackers, the separation systems we built. So all of these things normally you would aggregate from various suppliers, but we have such a wide and diverse satellite component business internally that we're able to pull these things together really, really quickly and build these spacecrafts at both a cost and also a pace that's really unmatched.
Well, what's next for space systems in the near future is we've got 3 more coming down the pipeline for Varda. This bus specifically, we can support a number of different kinds of missions.
So Rocketlab is not just a launch company. We're building constellations of spacecraft right here in our factory in California.
The W2 mission is our second for Varda, and a third Pioneer spacecraft has just been delivered to Vandenberg Space Force Base for launch in the coming weeks. It is a very exciting time to be a part of our space systems team. If you want to design, build, and operate missions like this one, check out the careers page on our website for all the latest open roles. In the meantime, follow Varda and Rocketlab on X for real-time W2 mission updates.
While our spacecraft are hard at work on orbit, we're making big progress on the ground too, particularly when it comes to Neutron and its launch pad in Wallops, Virginia. Right now on your screen is a live view of Launch Complex 3, located in the Mid-Atlantic Regional Spaceport within NASA's Wallops Flight Facility in Virginia. It sits alongside the much smaller pad for Electron and HASTE, but there are of course quite a few key differences. The first is the most obvious. It's much, much bigger. Electron stands at just 18 meters tall, whereas Neutron is more than twice that at over 40 meters tall and up to 7 meters in diameter. Recently, Neutron's launch mount was installed ahead of the first launch, and you can really see the sense of scale from the people standing nearby versus Electron's launch mount next door at LC2.
Now, if you are familiar with our launch pads at LC1 and 2 for Electron, you will know that they feature a strong back to hold Electron in place vertically ahead of launch. Neutron's pad at LC3, however, will not feature a strong back. Instead, Neutron's landing legs will be held down by the launch mount itself. Each hold down is designed for a compression force of 2.1 meganewtons and a tension force of 2.1 meganewtons. Other recent additions to LC3 include 2 enormous LN2 vaporizers. These will be used to supply gaseous nitrogen for the vacuum and environmental conditioning system for Neutron when it's on the pad. And with that, the large infrastructure items are done and dusted at LC3. Now it is a case of connecting all systems together and running them through a vigorous test and commissioning phase as we count down to Neutron's inaugural flight later this year.
Speaking of countdowns, we are just T-minus 4 minutes before liftoff at LC1 for today's Electron mission. Here's what you can expect once those 9 Rutherford engines ignite, kicking off our 59th trip to space. Electron's journey to orbit takes just 9 minutes, followed by payload deployment just over an hour into the mission. It starts with the fiery business of liftoff. Fiery business. Shortly after this, just shy of 2.5 minutes into flight, we'll have burned through all the liquid oxygen and kerosene in our first stage, so those 9 Rutherford engines will shut down. Stage 1 and 2 then separate, and the single Rutherford engine on our second stage ignites to continue the mission onto orbit. Next, the fairing separates, exposing those 5 Kinéis satellites to space, ready for deployment.
And since Rutherford uses an electric motor to power its propellant pumps rather than a traditional gas turbine, Electron carries batteries on board to power those pumps. Our engineers and designers devised a very clever system of ridding ourselves of those batteries once they are depleted. This saves mass on the way to orbit. It is a process that we call battery hot swap. It allows us to switch to a fresh set of batteries mid-flight and is a milestone that takes place around 6.5 minutes into flight. From there, the second stage engine finally shuts down at 9 minutes into flight, and that's when the kick stage separates from that second stage and settles into a coast phase around Earth for around 40 minutes. The final phase is orbit circularization and payload deployment. About 52 minutes after liftoff, the tiny 3D printed Curie engine on the kick stage will ignite to circularize its orbit and shut down just before all 5 of those satellites are deployed in sequence to their final homes in space. All of that will take place in just 2 minutes from now. As we enter the final count, Electron will enter the auto sequence. This is when the vehicle takes over control and prepares for liftoff. Let's hand it over to the operators in mission control to listen in on that sequence.
And confirm all expected primary flight computer ASCOs are green.
Confirmed.
Clear call for auto sequence start at T-minus 2 minutes. LDs go for launch.
Vehicles full in internal power. AFTS is green and enabled for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow dome purge is enabled.
T-minus 20 seconds and counting. Ten, 9, 8, 7, 6, 5, 4, 3, 2, 1. Liftoff.
Beginning the turbo. Stage 1 propulsion nominal.
IoT for you and me is on its way to space. Electron has lifted off from the pad at Launch Complex 1 and has commenced its 9-minute...
3, 2, 1. Liftoff.
Beginning the turbo. Stage 1 propulsion nominal.
IoT for you and me is on its way to space. Electron has lifted off from the pad at Launch Complex 1 and has commenced its 9-minute journey to orbit. The vehicle has cleared the pad, so next up is max Q, or maximum aerodynamic pressure. This is the moment in flight when Electron experiences peak structural load. Let's listen in for that call out from Mission Control.
Cleared max Q.
And that's the call we're looking for. Electron has successfully cleared max Q. We're now at 15 kilometers in altitude and traveling at over 2,200 kilometers an hour. Up next is a particularly busy time in flight. Electron will go through main engine cutoff, or MECO, followed by stage separation and then second stage ignition. Having depleted all the propellant in the first stage, we don't need to carry what is essentially a giant empty fuel tank the rest of the way to orbit. So we jettison the first stage and continue the rest of the mission with just the stage 2. Let's listen in for those calls.
Stage 1 propulsion holding nominal. Stand by for MECO in approximately 30 seconds.
"15 seconds till staging."
Entering burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
There we have it, successful MECO, stage separation and second stage ignition confirmed. Electron's second stage is now continuing the mission to orbit with those 5 Kinase satellites attached to the kick stage. Very soon we can dispense of the fairing that has been protecting those satellites from the intense conditions of launch. The 2 halves of the fairing will split and fall away, exposing the satellite to space in preparation for deployment. Those are the magic words. Electron's fairing has been jettisoned. We are now at 3 minutes into flight with less than 6 minutes remaining in this second stage burn.
Hey Phoebe, discharge holding nominal.
With Electron's fairings gone, the payloads are now exposed to the vacuum of space. But we're doing things a little differently with Neutron. Neutron's captive fairing will stay attached to stage 1, and our second stage will be deployed from within. The fairing halves are large and complex composite structures, so we prefer to keep hold of them for rapid reuse of stage 1.
Stage 2 propulsion.
Some stunning views of Earth there from space as we head out over the South Pacific Ocean. T plus 4 minutes into flight, and Electron is soaring at around 11,000 kilometers per hour, passing through 180 kilometers in altitude.
So far, Electron has progressed through a successful liftoff, stage separation, second stage ignition, and fairing separation. These are all pretty standard phases in flight for all launch vehicles, but the next milestone is one that's unique to Rocketlab. We call it battery hot swap. The batteries powering the electric motors driving the propeller pumps on the engine deplete over time, and when they're drained, we eject them and swap to a fresh set for the rest of the journey to orbit. Watch closely and you might just see those batteries slip out of sight once jettisoned.
Throttling down.
Battery jettison confirmed.
Bye-bye batteries. That is a successful hot swap. We are now around 6 minutes into flight at an altitude of about 206 kilometers. We have sailed through most of the key milestones for this launch, with just a few more to come, including SECO, or second engine cutoff. At that point, the Rutherford engine will throttle down, eventually coming to a stop in preparation for kick stage separation. That moment will mark the end of the first mission phase, and it's coming up at 9 minutes into flight.
AFTS has saved.
So what you're looking at on your screen is our vacuum optimized Rutherford engine. It might look simple, but there's a lot of systems keeping everything running smoothly. Each engine, sea level and vacuum, has a dedicated engine controller which performs local closed-loop control computations for that engine. That involves sensor sampling, processing, and also position control of engine valves and actuators. This includes the thrust vector controllers, or TVCs, which gimbal the engine to give us direction. However, each of these engine controllers are themselves centrally commanded by the flight computer, which performs the overall guidance, navigation, and control for the entire vehicle.
Entered burnout detect mode.
You might remember earlier in the show we mentioned that Rutherford would begin to throttle down for shutdown. Well, we're now fast approaching that point. Soon you'll hear an operator call out entered burnout detect mode, and you'll know that SECO is close.
SECO confirmed.
Stage separation confirmed.
And just like that, Electron's Rutherford engine has shut down. That is a successful SECO and kick stage separation. The kick stage, still carrying the 5 satellites for Kinéis, is now in a transfer orbit. It will coast around Earth for around 40 minutes. After this, the Curie engine on the kick stage will ignite for a short burn to circularize our orbit in preparation for payload deployment. While we wait for that payload deployment, now's a good time to think about whether you'd like your work days to look like this as well.
Currently, we're hiring across our launch and space systems teams in the US, Canada, and New Zealand. So, discover what a career at Rocketlab might look like for you.
If you walk into any of Rocketlab's facilities, the first thing you'll read is "We go to space to improve life on Earth." And that's really the foundation of the entire mission of Rocketlab. So the way to think about Rocketlab is we're not just a launch company, not just a spacecraft company, we are an end-to-end space company. And I think what sets Rocketlab apart is you actually get to build hardware that goes to space. And not just go to space, but go to Mars, go to the moon. You're never a little gear in a giant machine. You get given huge responsibilities within the company.
If you come to work at Rocketlab, you can expect to build beautiful things that work beautifully. Don't expect 9 to 5, but do expect to have an actual meaningful impact on the world.
You have all of that and more to look forward to as part of the Rocketlab team. So jump on our website to browse those open roles and apply today. For now, though, we're going to take a short break and be back with you in around 50 minutes for payload deployment. We'll see you then. Welcome back. Just an hour and 3 minutes ago, an Electron rocket successfully lifted off for the 59th time, carrying 5 satellites for French IoT constellation operator Kinéis. For the past 50 minutes or so, those satellites have been coasting around Earth attached to Electron's kick stage, ready for payload deployment. About 10 minutes ago, we actioned our circularization burn, which was conducted by the 3D printed Curie engine. That engine is designed and manufactured by our team to provide in-space propulsion. It enables us to raise or lower orbits and conduct plane changes. It basically ensures that our customer satellites get to very precise destinations, often within single digits of the target. This is a pretty rare feat in spaceflight.
The satellites for today's mission will deploy in a very specific sequence. First up is a single satellite attached to the top of the kick stage, followed by the other 4 in pairs from opposite sides of the payload plate. Now, let's throw it back to the brains in mission control to listen out for those calls now.
Kinéis 1 deployment confirmed.
There we go, the first of 5 for today's mission successfully deployed. Now, if you keep an eye on the animation on your screen, you'll see some pretty slick dance moves from the kick stage to orientate us in a precise manner for the next deployment. Then we'll be flipping back the other way for the final sequence.
Kinéis 2 and 4 deployment confirmed.
Kinéis 2 and 4 now joining their siblings on orbit. This is the 17th and 18th satellite deployed for Kinéis, with 19 and 20 coming up in the next 30 seconds.
Kinéis 3 and 5 deployment confirmed.
That is 5 for 5, all payloads deployed to orbit. Congratulations to the launch team and congratulations to our mission partners, Kinéis. Welcome to orbit once again. Now we have one final dedicated Electron launch coming up for Kinéis later this year. This will see to deploy the 5 remaining satellites in their constellation, bringing the total to 25 spacecraft. We look forward to teaming up once again.
So with that, our 59th Electron launch is done and dusted. On to the big 6-0 next. We'll be sharing details of our next mission on our website and social media channels too. We look to ramp up launch cadence through this year, so thanks for joining us today and see you back on the pad soon. This is Rocketlab Mission Control signing off.